is our, we can choose it. This we can choose it. And this given, right? And we can choose this one too. This given, that given, that given, that given, that given. Only F, CDC, and KC are design parameters in here. Right? Only these three things that we can determine so that this is symmetric. Well, KC is no problem because that's itself. We can just make them to be positive definite. Easy. KC, we can make them to be KC larger than 0. Now we can choose any KC larger than 0. Now, can we have any CDC such that this one and that one so that they are symmetric? Right? I think I'm missing something. Do I miss something? I have a PC here. Sorry. So here's a PC. The PC. Yeah, I think I missed something. Right? PC. CCD. Right. Okay. So, how can I choose a BC and CDC such that this matrix is symmetric? We know this is symmetric, we have no problem. Because I can just do it, you know, pick up some values or some diagonal values. Yeah, positive. For example, and I say KC is equal to 2003, right? Yeah, positive. Any value. And as long as they are diagonal and they are positive, this is positive definite. Easy. Any value. All right? I don't want to be sooner or later in your homework number 5, number 4, and I tell you that I want to be frequencies the same as my system frequencies, then KC won't be like this. Okay, agree? All right. So that's. So when I choose, I say assume if B, if, yes, if here, B equal to CDT QBT, but it's given, B is given. So I say if, I give them there, I say if that is equation satisfied. What does that mean? It's already copied, right? Okay? All right. If this is a very important, also very easy to understand, CDT is QB, where QB is a matrix, is some matrix. What does that mean? Is B equal to CD? We know that B and CD are system matrix. They are not arbitrary. They are not arbitrary. if I assume that exists, what does that mean? That means B is in the column space of CD transpose. This means B is in the column space of CD transpose. What does that mean, is column space of transpose? Okay. If actuator and sensors are collocated, collocated that is always such. If they are collocated, then B equal to CD transpose. Yeah, Q means 1. If actuators and sensors are collocated, there are an S here. Assume you have many actuators. Each pair of actuator and cells and sensors are collocated. Then B equals CD transpose. That's also a requirement for PID control. All right. So, if they are not collocated, and there are some cases such that B is in the column space of CD transpose. Yes, they do have some special case like that. All right. Okay. If that's the case, then we'll be able to find F and BC. See, our BC and F, if you look at my chart here, then we choose BC because we know the QB from the QB here, QB transpose here. If that's satisfied, then QB transpose, we know that. We know the QB transpose. If we know the QB transpose, then I choose BC because that's my that's the parameters I can choose. BC transpose equal to QB transpose of CDC. And also F equal to CDC KC inverse BC, if I can choose that. This is the one I choose. Then you might ask me, how can I know that? How can I know I can choose this? Right? How do I know I can do this? Well, you can do the backwards. Then KD becomes like this. Then if I choose this, KT becomes symmetrics. By examining that, BCDC, this BCDC equal to CD transpose, QB transpose, CDC, because you sub this B inside there, this B is sub inside there, and then I can prove that becomes CD transpose BC transpose. That means BCDC equal to CDBC transpose. Right? If I can choose that. That means this minus BC DC equal to minus CD transpose BC transpose. I have a maximum of diagonal. Right. Now, let me just mix this. Alright, there's a lot of math here, but those are simple math, just the metrics. Now, let us rewrite the KT. KT equal to K plus BF CD and then minus B CBC, and we have minus BC CD and KC. Now I need to look at these two terms because I need to prove BC DC equal to the minus CD transpose BC transpose. Right? This to be, make sure this is symmetrics, then this one has to be that one transpose. Any matrix. If you give the any matrix, say any matrix, if I want to be KT equal to KT transpose, then I have to make sure this BCD equal to that term transpose. Agree? Correct? Any problem? No? Okay. And I also have to make sure KC is KC transpose, and make sure K plus BFD CD, that term equal to its transpose. Right? I have to make sure this is equal to that transpose. That equal to its transpose. That's no problem. It's check. Right? And if I do that, it's check. Right? That's a transpose.